Morning to one and all. So, in this series of first inception, today we are going to see how to find average grain size by the linear intercept method. So, we are using a primary method to find the grain size of a given microscopic image. So, here we are going to see that what is the average grain size by the mean linear intercept method. The various techniques or the methods are there to find average grain size. So one of them and one of the primitive, or I can say like easy one to find the average grain size. Let us consider we had a microscopic image obtained from an optical microscope. So we had an can see here we have an microscopic image, and you can see the at which magnification it has been taken out. Here it shows that the length of this line is around 200 microns. So when you change or take this image to other places or the other printout like this, the length of this, the image may change. So we have to consider this length of this line as a 200 microns and convert into our suitable scale bar. So here we're going to see how to find the average grain size. In this method, we are going to draw a few lines in this microscopic grid and find the intercepts of it. Then by this intercept, we are going to find the average grain size and the ASTM number G. So here the mean average length is given as L average is equal to N into L by P into M, where L average is nothing but the mean length of a grain, where and then STM G number is given as G is equal to minus 6.645 log of L average minus 3.298. So here the P is nothing but the sum of the intercepts after drawing the lines, where L is the length of the intercept lines, where M is nothing but the effective magnification, we can say, because we may draw the length of the scale different from person to person. So to convert it into equitable scale and effective, we consider here M as an effective magnification. So M is calculated by length of the scale bar used and the number next to the scale bar. So here the number next to the scale bar means in this microscope we see that it is in 200 microns. So when this 200 microns, what it scales to your bar of scale is nothing but the M. So we are going to see how to calculate the effective M in the next slide. So for the basic reason, as of now we can consider M as the effective magnification. N is the number of intercept lines we use. So here first we add an image. So we are going to draw a certain lines, maybe parallel or intersecting according to your convenience, and find out the various intercepts by each line. So here you can see I have taken 7 lines in this grid, and it's very important that all these 7 lines to be of the same scale and the same length. You can see that when I scale this material, I found that these 200 microns to be on my scale bar to be around 16.5 mm. So here the 16.5 mm is equal to the 200 microns on this image. So now we are going to find how many number of intercepts it has made by each line. So you can see that you can consider intercept is nothing but the transaction from one grain to the other grain. So we're not going to consider where it has been starting or ending in between the grain. We are only concerned in this method with the intercept it made with the grain boundaries. So we can see that we had some set of lines which have drawn here, like line 1, line 2, line 3, line 4, line 5, line 6, and line 7. So when I found out the number of intercept by each line, I got like the from the line 1. So you can see here it is 15 intercepts. The line 13, so line 2 has 13 intercept. In same manner, line 3 has 11, line 4 has a 12, line 5 has a 12, and line 6 has a 13, and the line 7 has 16 intercept. So I have taken length of this each intercept line as 49 mm according to my scale bar. So here you can see when I have taken a scale of my scale bar of mine and measured this 200 micrometer on the optical microscope image, it showed me like around 16.5 mm. So the 16.5 mm of its scale bar is equal to 200 microns in a simple manner we can say. Okay, so next we are going to find the ASTM G number and the average grain length. Here you can see the P, which is sum of the intercepts, is equal to 92. L, length of the intercept line, 49 mm, where M is nothing but the length of the scale bar measured to the of number of next to the scale bar. Here you can see length scale bar measure, we got it as an 16.5 mm, with the number next to the scale bar it is 200 microns. So converting 16 mm into the microns, we get 16.5 into 10 power 3 upon 200. So we get effective MI is 82.5x. So nothing but now we are going to, we have seen that it is magnified at 82.5 times, and n is a number of intercept lines. So here we used 7 lines, so n is equal to 7, and the average length is equal to nothing but L into n divided by P into m. Here 7 into 49 mm by 92 into the 82.5. So we get the average mean length as 0.04519 mm. So after getting the L average, we are going to find by the relation known before the ASTM G number. So ASTM G number is given as minus 6.625 log of L average minus 3.298. So here we get the G as substituting the L average value as 0.0459 in mm, we get G as 5.63, which is approximately equal to the 5.5 to the standard ASTM tables. So this is the procedure to find average grain size of a given optical microscope image. Thank you for watching.